Question 1. Diagram 1 shows the composite function gf that maps x to z. So the keyword here is composite function. And the composite function is given by this gf. Composite function is when we have two or more functions that is combined into one. So in this case, we have function g and then we have function f. And the convention that is normally used is by writing x as the argument of each function for gx. And then we have also the same convention for function f. But when we have a composite function that is gf like this, that means we have the whole function of fx to become the argument of the function g. So essentially, when we have gf of x, this is really mean g and then fx as the argument for function g. And then we need to know, if we have two functions, when we have a composite function that consists of two functions, which function do we need to start first? Which function that kicks in first? Okay, in this case, the first function that we need to execute is fx, the argument of the function g. So the inside function has to be executed first, and then only the function g will kick in. So this is first function to execute, and then this is the second function. So in this diagram, we have a function that maps x to y. And what function is that? That function is f. And then the function that maps y to z is the second function, which is g, the outside function. So if I'm going to write how x maps to y, it is like this. Fx equal to y. So x is the argument and y is the result. And for g, the one that maps y to z is like this. G, y is the argument to g, that equals z. So to answer the question A, the function that maps x to y, that is the function f. So f is the answer. Okay, question B. G minus 1 and then z. When we have minus 1 here, that means it is an inverse function that maps from z to y. So in this case, inverse function of g, that is g minus 1, argument of z, that equals y. So this function is basically mapping this z to y, and we call this as g minus 1. So that is the answer for question B.